L1, L2. Okay, so I have these 4 points, but someone state the obvious about these 4 points where each of L1 through L4 meet L. We only have 2 points, right? So if we only have 2 points on L, then like some of these are all the same. Also, more specifically, what do I know about the core 4 lines?
They already have intersections.
No, yes, but the moment we're going to run it, what we know is that no 3 of the core 4 meet at a point. So is it possible for all the core 4 to go through P1?
No.
Say no. Is it possible for 3 of the core 4 to go through P1 and the other one to go through P2? Also no, because never mind that. Because the core 4 have to, no 3 of the core 4 can meet at a point. So, since no 3 of L1, L2, L3, and L4 meet at a point, then 2 each must meet at each of P1 and P2. That's what we just talked out. Who's with me? Good. So, without loss of generality, let Q1 equal Q2 equal P1, and let Q3 equal Q4 equal P2. Alright, this is just a fancy way of saying, yo, let it be L2 and let it be L1 and L2 which meet at P1, and let it be L3 and L4 which meet at P3. Cool? Okay, now finally I can get a picture going. So here's L, here's my point P1, here's my point P2, and what I have now decided is that it's L1 and L2 which meet at P1, and L3 and L4 which meet at P2. Again, I had to have the core 4 lines meeting 2 at a point, because no 3 of the core 4 lines can meet at a single point. Is this picture kind of comprehensible? Okay, so once you get this far, this was the sort of like brilliant moves that were needed to get things going. We now see that there must be some other points of intersection, yeah? For example, anyone want to cite another piece of intersection? Okay, L1 and L3 must meet somewhere. Just they look like they're about to, right? So since L1 is not L3, okay, previously proven last class, by F, the core 4 are all distinct. Then by FPP2, let's call the intersection of L1 and L3, let's call it like X. Okay, so we choose to call this point over here X, the intersection of L1 and L3. Who's good? Okay. Let's also note that L2 and L4 must meet. So similarly, since L2 intersect L4, since L2 is not L4, again, previously proven, the core 4 are all different, by FPP2.
Please pardon this interruption. High school intervention classes are canceled for today. However, bridge project support with Ms. Hughes is still going on this afternoon.
Good.
Again, high school intervention classes are canceled for today.
Oh, there's so
Bridge
much
project
more still
support
left.
with Ms. Hughes still
Note.
on. Thank you.
Good. Let's quickly show that all the things are the way we think they are. Such as, dude, is X on L2? No, because if X was on L2, then what?
The 3 of the
Then
one.
L1, L3, and L2 would concur. But that would be a contradiction, yeah? So conclusion, X is not on L2. Next, is X on L4? Say no. No, because if x is on L4, then L1, L3, L4 would concur, but that's a contradiction, so x is not on L4. Can I just invoke a similarly? Similarly, what else do I know? No, I guess I can't. Oh, okay. Well, first let me make one more comment, which is also, if x is not on L2 and not on L4, then x can't be P1 or P2. It sounds really obvious, but it's a fact, right? Note x is on L2. No, x is not on L2, that's what I just showed. But what is on L2? P1 is on L2. On L2. Conclusion, x is not P1. And x is not on L4, but what is on L4? P2 is on L4. Conclusion, x is not P2. And also, since I will also note that x is therefore not on L, wait, why is that true? Oh, because it's not P1 or P2, and there are only 2 points. Okay, I'm now, because I'm running out of time, I'm going to invoke a similarly, because the argument is exactly the same. What are my other statements? Y is not on L1. Y is not on L3. Do you agree with these? Also, that Y is not P1, and also that Y is not P2, and also therefore that Y is not on L. Okay. Good. Forget it. So, that means that these 2 points, oh, I also need to show that x and y aren't each other. Well, x is not on L2, but y is on L2, right? Is that right? Right. Conclusion, x is not y. And also, that means, since x is not y, that there's another line through x and y. Let's call it M. So, by FPP1, since x is not equal to y, since x is not y, then I have a line M through x and y. X is on M and y is on M, as depicted. And can I say one more thing about L and M?
Hi, so sorry.
Can't talk right now. Someone, yes. Sorry, what? Good.
I'm just going to give
Good.
something.
Okay, good. Finishing up. What else about this line M?
It has to go through L.
Wait, yeah, that's true, but first I have to show that it's not L, believe it or not. Why is it not L? Oh, yeah, because x, have I already shown that x is not on L? I did. Yeah, so x is on M, x is not on L, so therefore, conclusion, L is not M. And if L is not M, wait, also I need to show that M is not L1 or L3. Why is that true? Well, y is on L1 and y is on M. Wait, so y is on L1 and y is on M. Is that true? Y is on M, but y is not on L1, is what I meant to say. So therefore, M is not L1, and y is not on L3, true, but y is on M, therefore M is not L3. Okay. Finally, I will say that since L is not M by FPP2, L and M must intersect somewhere. L intersect M must be some point. Okay, what is M really? M is this line that must go through the points of intersection of the pairs of the core 4. But now this line M, being very tediously we proved to not be L, also can't be, where's the contradiction going to come right now? M has to intersect L somewhere at this point Z. What are my two possible options? Z could be P1 or Z could be P2. But both aren't possible. If Z is P1, what's wrong with that? Then X and P1, then we have X on M, and we have X on L1, is what I want to say, I think. Yep. And we also have P1 on M, because I'm assuming that Z is P1. And I also have that P1 is on L1. But now I have two distinct lines, and here's why I had to prove that L1 was not M a second ago, right? I have two distinct lines, M and L1, intersecting at two distinct points. This is a contradiction with FPP2. And if instead M intersects L at P2, well now I have X on M, but X is also on L3, and I have P2 on M, because I'm temporarily assuming that M meets L at P2, and P2 is on L3. But now I have two distinct lines, M and L3, meeting at two distinct points. That is also a contradiction with FPP2. And so there's nowhere else for this line M to go, man. It can't go through P1, it can't go through P2, but we proved it to be a different line than L, and it's got to intersect L somewhere. So overall, we get contradiction. And thus, it's impossible for a line to have only 2 points. There's just too many other lines out there, and they all got to meet L somewhere, and they can't all meet at just 2 points. All right, that was like a little bit rushed. Who followed that? Mostly-ish kind of details. Good. You maybe like write it out for yourself or something. This video was 80% of perfect. Goodbye, internet. Later.